All right, this is my fourth time trying to record this video, so let's start. These are your notes for graphing sine and cosine parent function. Okay, so that's really important. You understand its parent function. So right here, one thing I need you to understand, is this first part. Like y is equal to sine theta. That is just me trying to give a name for the equation, y. I could have easily called it other things like f of theta, f of x. It doesn't matter, right? You know that we either plug in radians or degrees. They're interchangeable, but sometimes one is used more than the other one. For right now, it's going to start as radians. We're going to change it into degrees, but then very quickly in the next lesson, you're going to notice that we're going to be using only radians. So let's go ahead and let me show you the XY table basically that you're going to be using to graph sine. So we see here, right? We see here the sort of like an XY table. It just looks a little weird because it doesn't say X or Y, right? It says theta and then it says sine of theta. Just understand that I could have easily, this could easily say like f of theta if the equation looks like this, right? This y does not matter, okay? It's technically, for right now, it doesn't matter actually. It's technically just the name of the equation. So if we come to this xy axis, right, this is what we're going to try to fill out. I chose these theta points, right? I chose these inputs, basically. That's what they're called, right? Think back to back in Algebra 1, whatever, whenever you started graphing, right? The first part is the inputs, and then the y is the outputs, and then that's how you get where to graph on an xy axis. So we're going to go ahead. First thing I need you to notice is these are all in radians because they have, a pi. 0 doesn't have a pi, but you could easily put 0 pi and it'll be the exact same thing, right? It'll still be 0. So what we're going to do is we are going to change all of these into degrees because I know that some of you, and myself included sometimes, I like to work with degrees better than radians. So let's go ahead. 0 is still 0. Forgot the little degree sign. Pi over 2 is 90 degrees. Now, let me stop right now real quick. These right here, you already know how to do, right? It's using the little times 180 over pi to convert. That's all we're doing here. That's all I'm doing, converting, right? I don't want you to have to memorize this, but you know how to do this. 3 pi over 2 is 270 degrees. 2 pi is equal to 360 degrees. And this is actually going to be a little bit easier for us, or for most of us, because now when I think about what is the sine of 0 degrees, then it's something that you can actually figure out because you've done it so many times, right? So sine of 0 degrees is equal to what? Right now you're probably thinking like, well, I don't know, we're graphing, so it's something new, but it's not, right? Let me sort of take it back a little bit right now to the very beginning of when we started doing this. I'm going to sort of graph this right here. Sorry, I didn't like how that little circle looked, so I'm just going to draw a new one. So I lost my train of thought. Okay, so we're going to go ahead and use these real fast, right? And I'm going to take it real back, like to the first lesson, basically, of this entire unit. I'm going to draw an XY axis, and let's think about where would 0 degrees here go? Where would 90 degrees? Where would 180? Where would 360 go? All of this is stuff that you guys already know. And this is exactly why I changed from the radians, because some of you guys don't really know that for right now. So we know that the 0 is here, right? Because that means your standard angle hasn't moved at all. It's still the same terminal side. 90 degrees would be here, and then 180, 270, 360, right? It's right back because you make a full rotation. Every single one of these has a point based off of like our unit circle where we let the r equal to 1. So that just really means, we only go 1 away, or our hypotenuse is equal to 1, right? There's so many different things. And so then we get these points here. right? 1 comma 0 because you're going to the right one and you're stopping there. 0 comma 1 because you don't go left or right and you just go up, right? Remember, 1 is just chosen arbitrarily. I really don't know where, like, who or whatever decided, but it's just 1. You go 1 in every single direction. And so now you have to really, really think about, we are graphing sine. So this is where you also take it back to what you've already learned. What is the definition of sine? It is y over r, where r is the radius, but we've let r equal to 1, so then therefore it's just y. This y is not the y that I called the equation over here, in the beginning. It is not the same y. This is our rule y. The other one is just the name of the function. Okay, so don't confuse that. And so now we sort of have to understand, right? Sine is the y parts of every single point. Since you chose 0, right, we go to the xy axis and we decide, or not decide, sorry, it says it there that it's 0. And then sine of 90 degrees, you go and you look at what is the y part of it, and it's equal to 1. Right? Pause the video and really go look at that. Go look at the xy axis where we put 0, 90, 180, 270, 360. That's where all of this is coming from. Now, if you notice our answers, they're super repetitive and they're very basic. That's why, even though graphing is a new topic for some of you, it shouldn't sort of like give you guys a lot of trouble, right? Because you're just basically bringing together a lot of things that you know. That should say 360. I mean, it's okay with 2 pi, but just to be the same. Now, all those answers, right, it just came from this part right here, because the rule is sine is the y part. So that's what I did. I highlighted the y part. So now sort of the last step is just graphing. All right, that is really our last step. Looking at this xy axis, you're going to notice some couple of interesting things. The x axis is in radians. Usually when we graph in radians. Like I said, for some problems it makes more sense to graph in radians. If you really want to like look at those type of problems, you would have to like continue on to like honors pre-calc or pre-calc, stuff like that. So, but just remember though, right? Pi over 2 is the same thing as 90. Pi is 180. 3 pi over 2 is 270. 2 pi equals 360. And so all that really happens now is I'm just gonna plot these points, basically what I figured out. 0, comma, the answer, which is 0. Pi over 2, comma, 1. Right, so 0, comma 0 would be that point right there, because that means I don't move. I am exactly at the origin. Pi over 2, comma 1. So I go out pi over 2, 90 degrees basically. And then I go up basically 1. Now, I don't want to put the dot here because the graph would look way too small. And let's be honest, like you wouldn't really be able to see it. So I'm going to go right here up to 1. And then same thing, I'm just going to go down here. If you notice, it's four steps. So 4 steps. So at pi over 2, I'm going to go up to 1 and plot my point. At pi, I'm going to go 0, so I plot my point there. At 3 pi over 2, I'm going to go down to -1, so I plot my point down over here, right? Because I'm just following what the table says now, basically. And then at 2 pi, I'm going to go ahead and plot 0. So plot my point right there. And so I want you to think about, right, what type of graphs you've worked with before. You've worked with linear, exponential, quadratic. Some of you have done the higher order polynomials. You really haven't seen something like this right now, unless you're like taking physics or something like that. So to connect the dots in one smooth motion, you basically do this here. You start at the 0, and then you go up, you go to the point, and then you have to bring it back down because our next point is this one. And so you get sort of this weird looking shape, but this is completely like 100% correct. I'm going to go ahead and name this line y equals sine of theta because that's what we're actually graphing. And that's how you graph the parent function, right? It's not a lot of work. The reason why, I wrote y there is because, let's say for whatever reason I graph something else on the same graph, because I wrote y there, which graph like to look at if I say, hey, look at the graph of y or whatever. And so one very important thing I need you guys to understand is this part right here, this graph, is only a really small part of the entire sine graph. So really think about this here. In our standard position, I can just keep going over, like just keep rotating like so many times, hundreds, thousands. And if you notice, I drew it in a positive direction. Did I? I don't know which direction is that because I don't remember where it started. But anyways, I could go in either positive or I can go negative, but I can just keep going forever. And the answers will always be the same. I'm going to either get 0, 1, or -1. And so what happens is that the graph just repeats. Yeah, sorry about that. And so the graph just repeats over and over. Nice. And so we go ahead, and what I can do is just think of it as it's starting at 0, going up to 1, coming back to 0, going down to -1, and then going back to 0. For instance, 0, going up to 1, going to 0, -1, and then 0 again. And that is the same process. So after this, it's going to go up to 1, down to 0, down to -1, right? And that's the really, really nice part about sine. You already know how the graph looks just based off of, your work from before. Yeah, that was a horrible graph. So let me try again. So what I'm doing here is actually pretty interesting, and for some of you guys, this is going to help a lot. So if we go back to the table, right? Go back to the table and then see that it went 0, 1, 0, -1, 0. The pattern is the 0 basically repeats every other step. So that's what I'm doing. I'm going 0, that's going to be our 1, 0, -1, 0. So that's what I did over here. It's not exactly a mirroring, right? Because if you notice, this here is going to be up at 1. And if you would mirror across the y-axis, the dot would be here, but that's not what's going to happen because it's just going to continue. So if we really are reading, from left to right, we would start here and go here. That is one, basically like a rotation if you really want to think about it like that. And so what that means is you're going to start here and end here for the same exact rotation. So it's actually going to go up here to 1 and then come back down and then go down to -1, right? In order for it to have like sort of the same exact curve. And so that's what I'm going to draw right now. Right? That's these 5 points right here. That's the real pattern for the sine. You go like sort of origin, you go up 1. This number is going to change eventually. But right now it's a really nice 1 and a -1, right? That's where it's going to like peak and then go down. And so notice how, right, that's what I'm doing, right? So if this one is going that way, it goes from 0 and then it goes down -1. And so that's what I'm doing right here, going to the left. I really want you to like think about here how I drew this. I drew it from left to right, connecting it to this other one, which I drew from left to right, right? That's how you want to think of it, as like it repeats. I draw the arrows because technically this graph goes on forever. It never stops. Now, sometimes it makes sense for it to stop or for us to force a stop. And that's called, restricting the domain. But just understand that it just keeps going forever. Because all we keep doing is just, here goes 360, and then here goes 360, and then here goes another 360. And it doesn't really look like it right now, but all of these little peaks and like these little right here on the bottom, those are going to go only up to 1 and down to -1 for right now. You could get way more complicated looking like sine graphs, cosine graphs once you get to like physics, when you deal with like damping and things like that. But for right now, it's just going to always go either up to 1, down to -1 for our parent function. And this is the parent function for sine. We're going to be doing the exact same thing for cosine with the table, with the xy axis. So everything you already know, but it's just basically creating or like a different representation of it.